So today, like I said, it's going to be a pretty quick lesson. That's why I don't want you to have anything out right now, just because I don't know if I'm going to have you write too much today. I would love to just kind of teach it to you. We practice it, and then that's it. We can kind of move on, okay? So it says, so this is lesson 12, okay? We're going to multiply a decimal by a fraction. Sorry, blah, blah, blah. No, we're not doing that. Multiply a decimal fraction by single-digit whole numbers, which is exactly what we did yesterday, okay, or the day before, sorry, the day before, including using estimation to confirm the placement of the decimal point. So that's the new addition today. So we're going to kind of take a break from, like, typical multiplication of decimals, okay? Lily, close your desk. Okay, when you're looking in there, you're not really listening to me, okay? So we're going to take a little bit of a break from like our typical way that we multiply decimals, and we're going to kind of do it mentally today. There's going to be a lot of mental math, okay? But you guys can do it. You can totally handle it, okay? Let's see. We're going to kind of talk about this a little bit, just like verbally, just to get a little bit of a warm up, okay? So my friends, 5 times 3 ones, so think about what that is. 5 times 3 ones. When I snap my fingers, you're going to tell me the answer with the unit. Okay, so you're going to say it in unit form. Are you ready? Yeah. Everybody understand what I mean?
Yeah.
Okay.
1 and 1 times.
15 ones. 15 ones. Good. Okay, so 5 times 3 ones gives me 15 ones, right? Good. So right there, we just did 5 times 3, which equals 15. That's like the standard form multiplication sentence. Make sense?
Yeah.
Okay. So then the multiplication sentence in unit form would be basically 5 ones times 3 ones equals 15 ones. Okay? So then if we look at this one, okay, use the same mentality. Nothing really changes except for the unit. Okay? So 5 times 3 tenths. I want you to tell me the answer in unit form. Are you ready?
Yep.
5 times 3 tenths.
5 tenths.
Good, good. I am just looking for 15 tenths, but if you said 1 and 5 tenths, you are also correct, okay? So 15 tenths, right? If we're thinking just very simply, 5 times 3 tenths gives me 15 tenths, right? But of course, we would write it, I'm actually going to do it down here. So we did 5 times 3, oops, my bad, times 3 tenths equals 1 and 5 tenths, right? So this is kind of what now it looks like in standard form. But remember, we can say this as 1 and 5 tenths, but we can also say just 15 tenths, right? Does everybody get that part?
Yes.
All the language that we're talking about? All right, cool. And then last but not least, right, probably could have guessed what we're going to do next, right? So think about what I wanted you to say up here, and you're going to say it down here. You ready?
Yeah.
Okay, so just keep the same unit. 5 times 3 hundredths, go.
1500.
Good, 15 hundredths. So if we keep the same unit, yeah, we're going to say 15 hundredths. But then when we look at it in standard form, it's 5 times, okay, 3 hundredths, which looks like that, right? Does that look familiar? Okay, are we starting to understand kind of where our numbers fall when we're talking about like decimals and that sort of thing? Like hundredths always is the second place value over, right? So there's tenths, hundredths, thousandths. So if there's no tenths, you have to write a 0, right?
Yeah.
Just kind of keep that in mind. All right, beautiful. So then our answer is 15 hundredths, which in other words is 1/10 5 hundredths, right? I'm going to write that like up here. So 1/10 5 hundredths or 15 hundredths, right? Because that 5 is in the hundredths place, which means if we smush it together, it's 15 hundredths. So a little bit of review. Any questions on that?
No.
Okay. If you can do this, then you're going to be in pretty good shape. Okay? All right. So I want you to look at these problems. Okay, you're not going to say anything yet. So look at these problems, and we're going to think about how they are alike. Okay, meaning how are they similar? How are they the same? Okay, so 31 times 4 equals 124. 3 and 1/10 times 4 equals 12 and 4/10. 31 hundredths times 4 equals 1 and 24 hundredths. Okay, so like looking at what that looks like, okay, I'm going to give you like 20 seconds to talk to your group. How are they similar? Go.
They're all like this. They have the digits and units, but that changes. Like they're all the same number. The numbers. Yeah, so like they go backwards. The decimal moves to the left, and the numbers to the right. Yeah, that's where the numbers are. The digits are the same. Yeah, the numbers are the same. The numbers are the same, but the digits are
Okay, 5, 4, 3, 2, 1, 0. All right, beautiful. Okay. Let's see. Wiggly Wolves, can someone from your group tell me, like, one thing you talked about? Done it.
We said that the units move to the right, but the digits stay the same.
Good. Yeah. So when we're multiplying, right? Technically, kind of they move. Anytime we multiply, they move to the left. But you're right in saying that, like, they get smaller, right? When we're multiplying by a smaller number, right? Can we all agree that 31 hundredths is smaller than 31?
Yeah.
Yes, right? Because 31 hundredths isn't even a whole number yet. Notice how there's no number in the ones place, meaning that it's not even a whole number yet. So it's really, really small. So kind of bouncing off of what you're saying, Donna, like when we multiply by a smaller number, we are going to get a smaller answer, right? The number is going to get smaller. So if we think about, this is like really familiar to us, right? 31 times 4 equals 124. It's all whole numbers, all very big. But then as soon as we throw a decimal in there, right, our number starts to get smaller. What's something else? Let's see. Crispy Bacon, what's something else you notice about these three problems? Emma?
Like they're all in it's all the same number, but there's decimal to 100 different units.
Good, yeah, so they're all the same digits, right? Digits. Everybody point to those and say digits.
Digits.
Digits, good. So each individual number, like this 3, this 1, this 4, right, those are all digits. They're all the same digits, but as soon as you throw a decimal in there, it changes the value, right? Changes where they fall on the place value chart, right? Changes the value. Good. Okay. Lily, what do you notice?
Like kind of off of what Emma's saying, like they're all the same digits, but they're not all the same number.
Good.
They decrease as they go on. Because they look similar, but they're very, very, very different.
Yes, I totally agree. Yeah, that's exactly it. They're different numbers, different values, right? So that decimal is tricky. It kind of changes what's going on, right? Jackson?
They're all being multiplied by 4.
Good, yeah, they're all being multiplied by the same whole number, which is important to notice, right? Because even though they're all being multiplied by the same thing, since a decimal is being thrown in there, right, it's going to change the value of the number, even if they're all being multiplied by the same thing. Good, all right, so I think we pretty much fleshed it out, but one thing to notice, okay, that I kind of want to draw your attention to, we're going to kind of look at these two for right now, and then I'll talk about that one later. So 31 times 4 gives us a big number, 124, right? We know that we can kind of round 31 to, so this part's really important. So if you're starting to get distracted, I would close your desk, maybe turn your body towards me, something like that, okay? So we can round in our head 31 to like about 50. If we're thinking in terms of like 25, 50, 75, 100, like thinking of like quarters or something, we could round 31 to like about 50, right? So we know that 31 multiplied by 4 has got to give us somewhere around 150. We're like, so we can kind of use our knowledge of rounding to help us estimate what that answer is going to be. So it makes sense that 31 4 times is going to be a big number, like 100 something, right? But then when we think about 3 and 1 tenth, right? 3 and 1 tenth, that's just 3 dots, right, in the ones place, right? Whereas 31, if we're thinking about, let's say we're thinking about eggs, okay? Having 31 eggs versus 3 eggs, we can notice that 3 and 1 tenth is smaller, right? So when we think about that, we know that 3, if we were to just multiply the whole numbers, 3 times 4 is 12, so we know our answer has to be right around 12, right? So we can use the whole numbers to kind of help us out with that, okay? Questions on that, like what I kind of just mentioned? Okay, Charlie?
I didn't really get it.
That's okay, that's okay. So bottom line, what I want you to notice and what's going to be important for this lesson is multiplying the whole numbers, and then the decimals come into play later. So right now, Charlie, on 3.1, which digit is the whole number? The 3, yeah. So if we were to ignore the decimal fraction, which is the 1/10, if we were to ignore that for a second, it becomes 3 times 4. What's 3 times 4? 12, good. So 12 right there is our whole number, right? And then the decimal fraction comes in after that. So basically, knowing how to multiply the whole numbers is going to help you to know where the decimal is going to fall. Okay, and we'll talk more about it in a second. Okay, go, Donnie. All right, sweet. Yeah, so then this is kind of like the main point here. I see a lot of people who are literally slumped over, not looking up at me. So please pick your heads up, turn towards me. Okay, find a way to not be sleepy or distracted right now. Okay. All right, awesome. I'm almost done. I promise. I promise. So pick your heads up. Everybody pick your heads up. Show me what it looks like to be a 5th grader in a math class. If Mr. Carroll were to walk in right now, how would you want to be sitting? Hey, awesome. That's what I'm looking for. I need you like up. Okay, take this seriously, please. Yes, I know, it's hard. It's hard. Okay, we're almost done. We have, give me 10 minutes and then I'm done, okay? So it says you can multiply the numerals first, meaning the whole numbers, okay? So if I had something like 2 times 13.7, okay? I can multiply the big numbers first, right? The whole numbers, the numerals first, okay? So 2 times 13 is 26, okay? So I know my answer should be somewhere around 26. Do you think it's possible that it could be more or less? Yeah, it probably won't be exactly 26, but that's okay, right? It means it's going to have something kind of after that, right? So 2 times 7, right, is 14, of course. So then the 4 stays here, the 1 adds over, so it becomes 27.4, right? But even though our answer isn't exactly 26, I know that I'm in the right ballpark because 27 is pretty darn close to 26, okay? Yes, Lily.
What you said earlier with the adding after.
Mm-hmm.
So what if there was a number like a big number like in the thousands, like the number we had earlier, 3 and 2. How do I say this? There's so many 2s.
It's okay.
I'm trying to think.
So just that there's a big number in the
like
thousands place.
Yeah.
Uh-huh. So do you remember what I did with the area model yesterday where I would push it over, keep adding it over? That's what would happen.
Okay, so basically if say we had this, but it was 1 and 37.
Mm-hmm.
So basically and it was 4, so I'd just if it would make a bigger number with the 3 or something, and so I would just push it over until it got to if it was 12 and 2 or something.
Mm-hmm. Mm-hmm. Yes. Yeah. So bottom line, you're gonna keep pushing it over, but remember that after this, we're gonna do standard algorithm, and that part will make a lot more sense. Yes. So today, so I'm just gonna bounce to what we're doing today because I think that will be a little more helpful. Okay. I guess I'm getting ahead of myself. Okay. So I am gonna ignore this question just because I find it to be a little more confusing. So the smallest unit in 5 and 1/10 is the 1/10, right? Tenths.
Yeah.
Too much. Okay. So if we were to kind of smush that over, the number would become 51/10. Do you see that?
Yes.
So 5 and 1/10, if we were to smush it over, it becomes 51/10, okay? Suppose our multiplication sentence was 51 times 6, which now it is. If we smush it over, right, instead of 5.1, it becomes 51/10, right? So then we can multiply 51 times 6. Do you see how we're working towards the standard algorithm, right? And then we'll put in the decimals later. So since I smushed everything over to the tenths place, okay, I can now do 51 times 6. Okay, so 6 times 1 is 6. 6 times 5 is 30. Okay, but when we think about, actually, hold on. I'm getting ahead of myself. So 51 times 6 gives me 306. That's my product. Okay. The product, the answer to this question, 5.1 times 6. The product will contain these digits, but is getting 306 reasonable for multiplying 5.1 times 6? Okay, so some of you are saying no, okay. So I want you to talk with your group. Why does it not make sense to get 306 when we multiply 5.1 times 6? Okay, kind of think about what I was talking about before this. Use your own noggin too. Why does it not make sense to get 306 from that multiplication sentence? Okay? Talk to your group. Go. Okay, 5, 4, 3, 2, 1. All right. Someone from Looney Tunes, give me the lowdown. What do you think?
So the 5.1, it would always have decimal because, well, the decimal always moves. It doesn't just stay there. It doesn't just go away. It always is there.
Yeah, the decimal does not disappear, right? It's got to be put somewhere. Good, good. Exactly. We're getting there. Jackson, do you want to add to that?
Yeah, kind of. But like,
Okay.
If you 51 and you add a decimal in the middle of it, it's no longer 51, it's 5 and 1.
Good.
So you get 36, not 306.
Good, yeah. So, good. The 0 would still be involved somehow, but you're on the right track. So combining what Maddie and Jackson said, here we go. Here's the important part. Okay? Here's the important part. So we have to find somewhere to put the decimal. So like Maddie said, the decimal doesn't just disappear. It's got to be put somewhere, right? So then knowing that answer, okay, we have to find where we're going to put that in. So the most reasonable place for that decimal to go is right here, okay? Because if I were to multiply, so obviously 51 times 6 is going to give me a big number, right? Thinking about 56 times, okay? Takes 2 50s to make 100, right? So 2 50s, 100, another 2 50s, 200, another 2 50s, 300, right? So it makes sense for it to be a big 300 number. But like Jackson was saying, the number's not 51, it's 51 tenths, which is also 5.1, okay? So the value of that number is actually 5. Think of eggs again, like 5 eggs, right? So 5 eggs times 6 has got to give me around 30, right? Because friends, what is 5 times 6? 30. 30, okay? Which means that my answer to that problem is 30.6, okay? So this is what I was talking about when multiplying the whole numbers is going to be your best friend today, okay? Because check it out. If I just take the decimal fraction away, what multiplication sentence do I have now?
5 times 6.
5 times 6 equals what? Go.
30.
Okay, so it makes the most sense to put the decimal after the 30. Okay? Would it make sense for me to put the decimal over here?
No.
No. Okay? Because we still have got to have 30 as like our whole number, right? All right. Sweet. Go ahead. Yeah, go ahead and get out your hard whiteboard, okay, and your dry erase marker. A hard whiteboard. Quickly, quickly, let's go. Hard whiteboard, dry erase marker. Boom, boom, boom. Thank you, Looney Tunes. Very fast. I love it. I love it. Thank you, PBJ time. Thank you, Crispy Bacon. Crispy Wolves is working on it. Love it. Cool. All right, awesome. Can you please kind of look up here, and then I'm going to tell you what to write, okay? So, my friends, look at that number, 11 and 4/10 times 4. You're going to think about it. What is the smallest unit in 11 and 4/10? Okay, think about it. Don't say it. What is the smallest unit in 11 and 4/10? Go.
4/10.
Good. Just tenths, right? Yeah, but 4/10. We have 4 of them, right? But the smallest unit is tenths. So I'm going to kind of ignore this question again because I think it's confusing, okay? So basically what that's doing is it's wanting you to smush everything over to the smallest unit, okay? So follow me with your eyes really quick, okay? Remember, the further right that we go, the smaller it gets, okay? So tenths is bigger than hundredths, okay? Hundredths is bigger than thousands, right? So the further right we go, the smallest it gets, okay? So basically your answer to that is going to be the number furthest to the right is your smallest unit, okay? All right, so then 11 ones and 4/10 all smushed together in the tenths place would be how many tenths?
114.
114. Go ahead and solve 114 times 4 on your board. Go, fast, because 4th grade's waiting.
Oh,
I gotta give you like 2 more minutes. 2 minutes, okay?
oh no. I thought this was an extra.
Okay, find your extra marker. That's fine, find your extra marker. All right, cool. Even if you're not done, follow me up here. Okay, my friends, think about it. What is 4 times 4? Go. 16. Stop. Okay, what is 4 times 1? 4. Good. I didn't say stop answering. I just said stop getting crazy. What's 4 times 1? 4. Good. 4 plus 1. Go. 5. Good. And 4 times 1? 4. Good. So you should have gotten 456. Okay. So our product from that, okay, is 456. But we need to find where to put the decimal. Okay? So my friends, looking at 11.4 times 4, if I cover up the decimal fraction, which is the 0.4, right? If I cover that up, what multiplication sentence do I have now? 11 times 4. Think about it. What is 11 times 4? Go. 44, which means my decimal should go right about there. Okay? Does everybody understand why I put it there?
Yes.
If not, now is the time to ask. Okay? So using the whole numbers, if I multiply those together, I get 44, which means my whole number in my answer needs to be around 44. Is 45 pretty close to 44?
Yes.
Yeah, okay. What about 4? Is 4 pretty close to 44?
No.
Okay, so that's how you know that it needs to go right there. Okay, we gotta go. So please put that away, get your reading stuff, and go to the hallway.